Okay. Hi. Good afternoon. Good. So today we'll be talking about analytics design thinking with Microsoft Fabric and Azure, looking at designing scalable decision-driven analytics, as the case may be. And what we are trying to do is to look at the end-to-end of planning a design process in analytics. Design thinking generally has to do with it is putting human approach to things. So instead of putting analytics first, you put human first. So it is human centered. And that's what we'll be looking at. So we're trying to, at the end of the day, we'll be crafting ideas or models to which we can approach a analytics problem. People go through so many analysts. What they do is that once they have a analytics challenge or issue or something problem to solve, trying to create a solution, what people just do basically is to jump straight into tools. So okay, I can use Power BI. I'm very good with Power BI. I'm very good with Excel. Let me just start doing things. But what we are doing here right now is to take a step back and basically understand the process, right? It is not much of a tool is the cheap, is more like the cheapest thing to learn, to be honest. As there are so many tools out there, but if you don't understand the process behind those tools, then they become useless and they don't even give you the required results at the end of the day. It depends on the team you are working with. So if you are working in a team of product developers, product designers, product managers, engineering team, then you need to put in place something like, a basic understanding beyond the use of tools, beyond the use of your Power BI, beyond the use of your Microsoft Fabric, right? And that's what we'll be solving in this class. This class is about, the analytics bootcamp is a 10-week program. It's a 10-week series. And at the end of the 10th week, I strongly believe that we take you through Microsoft Fabric, and this is what we do over and over again. Once we finish this batch, we take another batch, and just like this. So you understand Microsoft Power BI, Microsoft Fabric, Azure, SQL. And why we are doing that is basically, but our major focus is Microsoft Fabric, right? But with this, you need to understand all other things around it, right? So I will just go straight there, do a deep dive into it now. First of all, my name is Tosin Ojo, and analytics engineer with it's almost a decade now. It's almost 10 years. Thereafter, working around data. So my first job was in operations. So it's more like I use data, but it was not called a data analyst. It was more like in operations. But what I do is more of the job of a data analyst. So what you do is to get data, clean data, analyze data, right? Yeah, I would say it's a data analyst role, exactly. And at the end of the day, what we do with that data is to make decision with the data. So write reports on that data and how it supports the next marketing for the organization. Right. Jits, do you want to say something? Hello? Okay. Yeah. So we just move on. Why most data projects fail? Most data projects fail not because of the tool, but because of lack of trust and lack of low adoption process in the process of in the data projects. Most of what people do or the analysts do is to first focus on two. So two first approach, which we are trying to tackle in this class. At the end of the class, we'll be tackling it. Why most data fail. Two first approach, low adoption, lack of trust. Then, if that is it, what is analytics design thinking? It's an human-centered analytics focused on decision. And it's also a way of doing analytics that starts with people and decision and not data and tools. There are basically 5 stages in analytics or in design thinking. Empathize, define, ideate, prototype, and test. So you empathize, you define, you ideate, you do prototyping, and you do your testing. So I will just explain each of the 5 stages. Now, the empathize is basically understanding the business user. It's basically understanding business users. And who are the business users in the real sense? The business users are the decision makers. For example, in an organization, so in order of hierarchy or in understand if there is any analytic problem or is any problem, there are business stakeholders who are involved in that problem. So, for example, if we need to create a particular department is struggling with visualizing their sales data. Who are the stakeholders in this? We need the sales guys, the marketers, we need the sales manager. It might not, and sometimes the stakeholder might not necessarily be the manager. It might just be someone who is maybe it might be data entry person, right? Might just be the data entry. So the core of the problem might be from the data entry perspective, right? So you might need to even do some sort of formatting on how they input their data set. So first is to understand the business user. Who are the business users? And most times, I think some of the errors we commit is that we always think that business user should be manager. No, it can be anybody, but you need to know who is handling the data, who is struggling with making sense of data. So you sit with them, and these are the people you ask the first question. The next one is to define, you frame the right problem, right? So when you approach and this is same thing even in product management, even in standard product management, or even as a business analyst, if you're working as a business analyst in anything, it's like same way. You frame the right problem, turn vague requests into clear problems, build dashboard, enable reach. So some guy just come to you, I need you to build dashboard for me. I need you to enable regional managers to identify low performing products. Those are sometimes the questions might sound vague. I want to see the sales report. I want to see this. I want to see that. That's what they will tell you. So what you need to do is to define and frame the right problem. Then the next is to ideate, think beyond the dashboard as stakeholder, as you are the analytics person in the team. You ideate, think beyond dashboard. Sometimes the best solution is not dashboard. It can be email, and it can be an email trigger. It can just be as simple as automation. So everything might not necessarily be about creating dashboard. And the next is prototyping. You build fast, not perfect. Speed can be greater than perfection. And this is applicable even in general product design. There's something we call MVP, minimum viable product. So if you are trying to ship a product, you ship it, you design fast and you ship it fast. Then you build fast, you ship fast, then you can reiterate. So the first minimum viable product is the uh, minimum minimum acceptable or minimum version. Yeah, is the minimum version of your product that you can take to the market. And what you do with it, it is to get feedback. You want the real user to use it and give you feedback while you go on to build a proper product, right? Uh, I know we are talking about analytics, analytics. So let's delve in. Let's just digress. We say, uh, for example, a tech company is trying to build a fintech product, right? What they do in the first instance is to build the minimum viable product, then they ship it fast into the market, get it fast into the market, and people test it, people start using it, and the backend developer starts improving on it, and they shift the next version of it, which is an upgraded version. And why they do this, why we do this, why this is applicable, or why this is the best approach is to save time and to save costs, right? You don't want to use your initial capital on hiring engineers, and same thing here as analysts. You want to when you are designing for when you are designing solution, either a dashboard, either a report, whatever. If the manager is saying, I need you to design this report for me, what I personally do is to design the first version. I make sure that because sometimes you don't even understand, you might not get all what they are, you might not get everything they have in mind when you got your first brief. And this is why I advise for all analysts or engineers. Make sure before you start any project, try to take brief of the project. Sit down with the stakeholder, ask questions, write it down, then go back to build your first prototype. It might not necessarily be the best, right? Don't always look for the fancy parts. Just look for functionality first. Then let them test it. Once that is done, then you can now and build a better product. So test, validate with user. Do they understand it? Does it help them decide fast? Are they actually using it? Because sometimes, and this has happened to me many times, someone is asking for a report. Someone needs something to be designed. At the end of the day, they don't use it more than once and they forget about it. And I spend more than 2 weeks designing this thing. And after that, they just abandon that and they move on to the next. So what happened to my 2 weeks of labor? It is gone because I want it to be perfect. I want to design the best. And sometimes what they need is just what they need from all these things is just to answer one simple question and they go on. But they don't know how to present that to you. So they just give you a whole lot. And when you design it the first time, they don't come back to it. They just use it first and move on. So key insight for me is that analytics is about decision and not data. What is data and data platform? Right? It is a system to collect, process, store, and save data. So for those, excuse me, for those who are just joining, some people have been coming. I think they have network issues, but this will be recorded and it will be the recorded version will be available. So what we are talking about is analytics design thinking with Microsoft Fabric and Azure. And this is a series, in the series of 10 weeks, we have in a series in the next, like about, in the next 10 weeks, we have different aspects of Microsoft Fabric. We have practical session, demo sessions. We do more of hands-on. But at the foundation, we need to understand the basics, right? It is not always about on the tools every time. It's about understanding the basics, the fundamentals. So we work with analysts and you ask them what is like what are medallion architecture? Can you design medallion architecture? Asking questions like designing schema, um, asking some 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 questions that help in design a scalable product. But sometimes we just abandon those and go into two streets because we want to be able to use Excel, want to use Power BI fast, want to be able to create a spreadsheet and the likes. And this get us stuck many times because the world has moved past using tools. AI is taking over everything. And understanding the basics of this, it makes you a, above, yeah, because you understand the bit, the why this is it, the why behind everything. What is the data platform? Data platform are simply systems to collect, process, store, and save data. And there are many data platforms that we know. You think about anything, Fabric, Azure, in fact, Power BI, um, um, Excel, your SQL Server, your uh, every like almost everything I can think about that handles the collection of data, the process of data, storage and saving data. I mean, serve data. Those are data platforms. But at the moment, we'll be focusing on Microsoft Fabric. It's a unified Microsoft Fabric. Sorry, sorry about that. Microsoft Fabric is a unified analytics platform that has end-to-end capabilities. So it has the ability to run an end-to-end system such that from the point of data ingestion to the point of visualization, you can run everything, excuse me, within Microsoft Fabric. So just before I move on, I just want to be sure that you can hear me and we are together in this class. Um, Chuku Funaya. Yeah. Okay. Thank you. Thank you. Okay. So we have modern architecture with fabric, and the modern architecture, like we know, in generally, there are two, or let me say, yeah, there are two major ways of data processing through which either the ETL or ELT. ETL is extract, transform, load, and the ELT is extract, load, transform. And every one of them has different use cases, right? Um, so this is just a typical of modern architecture with Microsoft Fabric: ingestion, storage, processing, warehousing, and the visualization. A typical example of how you ingest data using Microsoft is using Data Factory, and I will quickly show you how Microsoft Fabric looks like. So you can see my screen. This is, yeah, okay. So yeah, this is Microsoft Fabric, and to access it is just fabric.microsoft.com. And to you need to start it, you cannot open Microsoft Fabric or use Microsoft Fabric with your Gmail account. I think the least you can use is to use Outlook, create an Outlook account, or you use an organizational account for Microsoft Fabric, or you register as a developer on Microsoft and use the Microsoft developer account. So when you register a Microsoft developer account, it gives you an email, and that email address you can use. You can use it to register to open your Fabric account. Yeah, please, if you have used Fabric before, please can you give me a thumbs up? Okay, thank you, Jade. Thank you a lot, Boston. Okay, good. Right. And this is just Fabric account, and yeah. So you start basically with your data ingestion. You create your workspace. Create your workspace. After creating your workspace, then uh, do your you ingest your data with the with data factory. Then you go into one lake. One lake is as it is. One lake is a unified storage data storage system, Microsoft Fabric, and that's where you have your data being stored in different formats. We talk about that processing. You can process your data with in different ways. You can use the notebook. You can use the Spark. Um, you can use SQL, and also in warehousing, you have Fabric. Where so you have the Microsoft DW, and for visualization, you have the Power BI. Right. So for ingestion, we have the data fabric, storage, one lake, processing, Spark, or other ones. Warehousing, we have Fabric, data warehouse, and BI. For Lakehouse, Lakehouse is simply Lakehouse is more like if you break it down, you have lake and house. So that's where I think I put it. You have data lake and you have data warehouse. So it combines the characteristics of data lake and data warehouse. And what's the major difference between data lake and data warehouse? Can someone help me if you're in the core data warehouse, data lake, and data warehouse? You have difference between the two. Hello, hello. If you can type there, that'll be fine. If you can talk, that's fine. Just unmute your mic and speak, please. Data lake, data warehouse. Yeah, data lake stores both structured and unstructured. Data warehouse is majorly for structured data. Thank you so much. Thank you for this. Yeah, that is it. Yeah, and lake house, data lake, then data lake. In fact, from the way it's the diagram, or from even when you look at what's it called, Microsoft's documentation, it's more like lake, and lake as normal lake of water, right? It has water coming in, right? Maybe clean or clean, any form of, it's just a lake, it's just a data lake, it's just a lake. So it can store both structured and unstructured data. That's in data, you call it, you say structured and unstructured data. So if that is the case, so what are the storage formats for, or what typically do you call a structured data? It's example, structured data. So if you can type, please, what difference between, what is, can someone explain structured data and unstructured data? And with example, structured data and unstructured data. You can type, you are able to, if you can type, that's fine. Difference between structured data with example and unstructured data. Okay, someone is about to talk. Let's try now. I know you know this thing. You know this thing. You know it. You know this thing. Please, 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 so that we can move. So what we are trying to do is um, this or this boot camp, this session is not. You don't want it to be like every other sessions. Like we just jump into tools and we start delve into tools. We not even touch tools on the until third week or fourth week of this. So we have to at least deal with the fundamentals. And maybe in terms of revision, we revise it together, fundamentals and the likes. Yeah. The structured data as an enforced schema. Yeah. It is presented in rows and columns. Yeah. Yeah. Thank you. How about unstructured? Is it the opposite? We say it is opposite now. So if I go with this definition, I say that structured data does not follow a predicted pattern. It does not follow, there's no schema, no fixed schema. These are the characteristics of unstructured data. Does not have schema or no fixed schema, either to search. An example, typical example of unstructured data can be your email, can be PDFs, it can be social media posts. They come in like images, videos, audio, charts, and those are unstructured data. Yeah. Okay. Thank you. Structured data is organized in a predefined format, usually in rows and columns, easy to analyze. Yeah. Unstructured does not have a predefined structure or format difficult to analyze. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. That's it. Thank you. Thank you. So we know that if people are joining, for those who are just joining, the recording will be made available. However, I will also do a quick recap of everything we'll be doing just to bring us up to speed. So what we are doing is we are looking at the analytics design thinking with Microsoft Fabric and Azure. And why we are doing this is because we are not just jumping into use of tools. We're not just, I don't just want to next to teach Power BI, Fabric, start showing you how to create this, how to create that. No, 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 no. So what we are trying to, this it will be purely practical. This session, the next few sessions that we'll be having with practical, and you will have, it comes with case studies, right? So we'll be developing different case studies. You have to analyze some case studies. And if you have not, if we have not really registered for this, please do use the link wherever you, I don't know if you are, how you join this call, but make sure you register so that you can get email for to further your learning. And we hope that at the end of the next session, we have something. So it's spanned for the next 10 weeks, 10 weeks, 10 even more than 10 weeks. We'll be doing different aspects. So we're talking from SQL, we'll be doing deep dive into SQL, we'll be doing Fabric, Power BI, we'll be doing everything, like everything, and make sure we go there deep. And like I said, why we are doing this is because there are so many data analysts or data engineers who, what they know basically is the tool. What they know is the tool, but not the fundamental behind it. Um, so if you ask people about, imagine a data analyst, if you ask about uh, creating, okay, I mentioned that before, medallion architecture, uh, um, designing schema, what are schemas in the actual sense of things. You know, all these buzzwords that we use, lakehouse, data warehouse, all these things, we need to understand it. And yeah, so those are the things we'll be looking at, latency and the likes. So we're looking at so many things in the course of the session. Um, and we said why motor fail because there are two. First approach, what design thinking means is human-centered analytics focused on decision, human-centered focused on decision, human-centered focused on decision, and not on tools or data. There are 5 stages of design thinking: empathize, define, ideate, prototype, and test. This slide will also be made available. So we'll send this slide over. What are data platforms? And I mentioned that they are all systems used to collect, process, store, and save data. Then we enter into Microsoft Fabric as a unified analytics platform that runs an end-to-end with end-to-end capabilities. And we understand modern architecture with Microsoft Fabric that it has to do with data factory, which is the ingestion part, storage with OneLake, Spark, processing with Spark or Notebook, or using SQL, data warehouse with Microsoft, Fabric data warehouse, and lastly, visualization with the Power BI. And we explain, so we are on this one, Lakehouse architecture. And we said Lakehouse is simply it has the characteristics of both data lake and warehouse. And I asked that what is data lake, difference between data lake and data warehouse. Jit said data lake stores both structured and unstructured data, and said data warehouse is majorly for structured data. And I asked the difference between structured and unstructured data. So Jit and Chukwufunaya mentioned that structured data is organized and it has an enforced schema, while unstructured does not have predefined structure or format or schema. And that's it, yeah. And that's very correct. Thank you so much for that. Thank you for the contribution. So Lakehouse architecture, it has what there is one data copy, and it all structured and unstructured data. Then we mentioned two. So there are two ways where data are being generated or data are being produced, right? We said it can be, we have batch and streaming. So we have batch data and streaming data. I don't know if anybody's on the call who can give us, just explain if you know the difference between batch and streaming data. Batch and streaming. Batch and streaming. Okay. Streaming is real-time processing or movement of data. Yes. How about batch? So I don't take batch as the opposite, right? It's not real time. Yeah, is in batches. Thank you. Thank you. Yeah, that is it. That is it. So streaming data, an example of streaming data can be your videos. So for example, data that has been generated on YouTube Live. In fact, data we're generating now as we are recording this is streaming data. Why? Most and sometimes it requires and to how to undo batch and streaming data are kind of different. You handle them differently because streaming data it can be the volume. Yeah, stock market. Yes, thank you. Streaming data like stock market. So if you know stock market, you're always trading, and at that point of trading, you are looking at the graph. It's been going pam 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 pam. And those are the things that make it streaming in that sort of things. So look at this as English. Stream is flowing. So it's continuously flowing with in fact with almost time difference of 0.1 second. Pam 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 pam. And the volume can be high. But batch can be predictable, right? And for example, you have your sales figure for yesterday. You have a store and you want to you have data set of or you have you have the store record for yesterday. Those are batch. So you know that you go back to yesterday is a time frame, then you know can look at the sales we made yesterday, right? But stream data is coming constantly, pam, 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 pam. And to handle them, there are different ways. So traditionally, before now, most data set, most everything we build around data or any data is mostly around batch, right? But nowadays, with uh, data being the controller of everything, right? Data is at the center of everything we do, everything, right? So we now collect data from every source. As we are streaming now, data is being generated and it's being collected. Um, so with that, we need modern streaming insights. So we are going from batch to real time, from traditional to modern. In design principle, right? The design principle, so when we're thinking about design thinking as an analyst, is scalability, data quality, governance, accessibility, and cost. So scalability, how easy is can you want to scale? Then you are thinking about you're thinking about the scalability of your what you are producing in the production, production stage, how you get your um, the solution you are creating, how scalable it is, how the next level, then how you upgrade it, data quality, the quality of the data you are collecting. So have it in mind in your design principle, the governance. So governance is simply who have access. So accessibility, and yeah, that also speaks to accessibility, access, um, and security. Now, in modern data system, governance is very important. And that's why we have governance contracts, right? And it is simply, as an analyst, your work is right nowadays, there's AI. So your work is beyond just creating graph or creating charts. No, you can't be a data analyst that way, or a data engineer that way, or analytics engineer, I mean. You have to understand the principle. And for example, with Microsoft Fabric, or we have Purview, which is for enterprise governance. In fact, in Microsoft Fabric, there's governance around it. I think we have it in this slide. We'll be able to show you accessibility and cost. What's the cost implication to what you are doing? So all this comes into design principle: scalability, data quality, governance, accessibility, and cost. Governance in Fabric. who owns this, how secure it is, how do we secure it, then single source of truth. Those are the governance in Fabric. Summary of governance in Fabric. Data ownership. For example, when you create a workspace, right? Who owns it? Who can access it? Who can see it? Who do we give row levels access, or who do we give column uh, access? Who do we give this? Who do we give that? Those are governors. Who can see this? Who can see that? Right? In a department, can have sub team, and you want to put them into compartments, right? You don't want sub team A to see what is going on with sub team B, or you want data. You want to kind of separate what people can see and the likes, and yeah. So those are governance in Fabric. Connecting. So we have talked about this. Connecting design thinking and Fabric. Design thinking, that design defines problems, right? So design defines problem. Combining it with Fabric enabled scale. So Fabric will enable you to scale and your design thinking. So bringing it together, you have a design or a system that enables scalability. So this is just a case study review, analytics. And we know, so this is ingestion, storage, process, visualization. And I want to throw this open. I think I have a case study which I would like to read. Right. I'm looking for it. Customer. Right. So I have a case study. I think I will share that. Is a long case. So the case study is like a company wanted to understand customer sentiment across products. A company wants to understand customer sentiment across products, identify driver satisfaction and complaints, improve product quality and negative reviews, enable data-driven decision-making across teams. Now, the customer reviews were scattered across multiple platforms, websites, Amazon, and third-party retailers, mostly unstructured text data, not being actively used in decision-making. So the key challenge is that no centralized view of customer feedback. There is difficulty in quantifying customer sentiment, no clear link between reviews and product performance, and there is slow manual review process. Now, for you as an analyst, where do you think, how do you, what's, I don't know if you can hear me. So we said that the data is coming from websites, Amazon, and third-party retailers, mostly unstructured text data. Now, can you walk me through or give me a brief on how you will process that, collect that data, ingest that data, and visualize it? The data is coming from websites, it's coming from Amazon, it's coming from third-party retailers, and they are unstructured. Right? So what we want to use the data to collect, to understand is, we want to understand customer sentiment across products. Can you just give me a simple walkthrough of how you will attack that? You have an unstructured data that is scattered everywhere. How do you collect it, put it together, store it, process it, visualize it? I don't need to give me a Just tell me, I will ingest data, store it somewhere. Yeah, okay. You say pull everything data from all sources into a central repository data lake. Okay. Okay. Yeah, I like that. Another person, how do you pull all data sources together? Just doesn't have to be correct, right or wrong. No, there's no right or wrong here. You have unstructured data, and we know what example of can visualize what unstructured data looks like. Unstructured data can be email, can be any data that's coming from different. Okay, yeah, refine the data into a single source of truth, then draw your analysis. Thank you, thank you, thank you. Do you have any other contributions? I have my data from different sources. Thank you, Jit. I think that answers it, to be honest. So you pull your data, all your data sources together, get into a simple repository or a simple system, um, then process it. So you store it, then you processing, and then you visualize it in that way you want to do it. And the process of, you can use different ways to process your data. And that's also what we call transformation, to transform your data. You can use different things, depending on the tools you know how to use the best. If you are good with SQL, yeah, you can use it with Fabric. If you are good with Python, then that works for you. If what you are good with is Spark, that is good for you, right? So the major thing is to make sense of that data. Mm, make sense of that data. Thank you. Right. So this can be a simple one. Get your data into data factory through with data factory, of course. One lake system, data lake. You can use a notebook. This is just and use your Power BI to visualize it. Why Fabric matters? So Fabric is like I said, is a unified platform. It's faster and low complexity. The future of analytics is basically speed. The speed is greater than volume. Yeah, the volume of data is not about it, it's the speed. And that's what we say about streaming and batch. Key takeaways from this is that start with decision, design for user, and scale and build to scale. That is the essence, whole essence of this discussion in this class today. The summary of everything we are saying in this class today is that start with decision, build for design, design for users, and build for scale. So build it to scale. Okay. Yeah, I think she used Python. Anyway, for web scraping, I think Chukuna is we still get into that, and that's why we are starting this class this way. And I sincerely love this way we are doing it. Why? Because it gives context to everything we are doing. It explains the theory behind the theory before the practical, right? So I'm not just saying, oh, for example, say OpenExe creates 3 columns. All those ones, I know that all of most people know it. So there's no. So it is this class. It is this session is more and more of demo, right? Practical and practical. But I'll be laying the foundation, and from next class, then we go deeper, and I think I should be able to show. Yeah, so we'll be talking about SQL. So we do practical on SQL. We do web scraping. I think there's a session for web scraping. We do work with AI, agentic AI for our system. We also do sessions on Fabric and Power BI. So yeah, just stay tuned throughout, and the video will be made available also. So that's fine. So for and I say thank you. So if you have any question, I can take your question now. So let me ask. Okay, Jude is asking question. Yeah, even for web scraping, for web scraping, there is beautiful soup. There are so many APIs to use for web scraping these days. So yeah, beautiful soup with Python as Python library for web scraping. Don't worry, we'll get there. Don't worry. Don't worry, we'll get there. And anybody question any question on design thinking as an analyst? Any question? Any question? Any question? I'm happy to take your question. Any question, please? Okay, so if there is no question, then please be expecting a case study. I will send you a case study, which I will need you to simply write something for me on. I want to see your thought process. I want to see your design thinking process on it. So I will send a case study, then you will apply your design thinking process to it. Okay? Is that fine? Are we good? Okay. Right. If there is no question, then I will say thank you so much for coming today, and I will see you uh, next weekend, next week Saturday. Please look out for your email. Look out for email from us, and we see send email across for the time and the next time and the next session. Thank you so much. Bye.